All right, here we are for part 2 of beaches and coastal areas. We're going to talk a little bit about wave action. So obviously the driver of wave action is weather. And so when we talk about weather, heat source is the sun. Obviously the sun drives the water cycle and creates wind and weather patterns that circulate energy on the surface of the ocean, generating waves. And waves are primarily the force or erosional agent that shape coastlines. And so waves actually are defined by different pieces and parts. You've probably heard of the crest of the wave, which is the top. The trough, which is the bottom of the wave. The wave height would be the vertical distance from crest to trough. And then the horizontal distance is the wavelength. So I've drawn this like waves you would see on the beach, but obviously when we're talking about waves in physics, it looks more like this. So these are transverse waves. The wavelength would be from crest to crest, from here to here. And obviously, this is going to vary dependent on weather and ocean currents, again, driven by energy transfer from the sun and wind. So, wave characteristics, the height, the length, the period, which is how frequent the waves pass a given point, are all dependent on wind speed primarily, and also duration, so the amount of time the wind has blown, and the distance that the wind has blown across the surface of the ocean. Waves can travel huge distances, and wave energy, as it moves forward, the energy is moving, the water itself is not. So this is kind of a misconception. Again, it's energy transfer, not transfer of mass in the form of huge volumes of water approaching the shorelines. So here's what that looks like in a cross section. You've got your crest, which is your peak of your wave. Again, here you've got your trough. You've got wave height, which is a measure of kind of the average between crest and trough to the peak. And then you've got your wavelength, which is a measure of distance from crest to the next adjacent crest. And then you've got particle motion in the form of kind of these little concentric circles here, right? And obviously that particle motion is dependent on the source of energy, which is wind action. And so with depth, you're going to see a dissipation of that particle motion within the water. And that motion is circular, even though the energy is being transferred from left to right across this cross section. Here's just an example of wave energy and its transfer. And you can see here with the toy boat is actually moving in that circular concentric motion, and it's starting and then stopping in the same location, whereas the energy transferred from the waves is moving forward. The water itself is moving in this pattern, right? The deep ocean is unaffected by waves, which makes sense if winds are primarily driving the waves on the surface. When waves approach shallower depths, that's when you start to see a change in the height of the wave or amplitude. And that's because the trough of the wave actually gets caught on that shoreline that extends beyond the beach, right? So when the trough meets the bottom or the sea floor, the bottom of the wave kind of gets stuck or slows, and the top of the wave has no resistant force, and so it starts to build in height, and then eventually, because it's moving faster, the height of the wave is kind of moving at a different rate than the bottom of the wave, and that's where you see the cresting or breaking of the wave, and then the eventual collapse. So this is a better way to look at it in cross section. So here you can see at depth offshore, you don't have that interaction between the bottom of the wave and the shoreline. And then when you get closer to the shoreline, that's when that energy starts to see a force that is causing it to slow down. So it meets resistance, and the trough of the wave catches the shoreline, slowing motion at the bottom, and then the top of the wave, which is not experiencing that resistant force, is moving faster, and that's when you get an increase in height and then eventual cresting or breaking of the waves on the coast, right? So that's a simplistic representation of this. Obviously, when we're talking about wave action, there are other variables at play. For instance, if there's a storm system and the winds are blowing more forcefully, you might see a difference in velocity. So the top of the wave is moving much faster than the bottom of the wave, and you tend to get these big breakers that occur more frequently. So other variables obviously affect this. The other thing that can affect wave height for you surfers out there is the shape of the shoreline. So again, if you've got a gentle slope, that's going to produce waves that tend to be smaller in terms of their amplitude. Whereas if you had a steeper slope, you're going to tend to get breakers or waves that crest with bigger heights. That's a little bit exaggerated, but you guys get the idea, because this provides more frictional force over a distance. All right, speaking of force, waves can carry a tremendous amount of energy and then exert a lot of force when they hit the shore. And this is really the driver of erosion that happens along coastlines. So erosion is caused not just by the waves, but also the pressure of impact on the coastline, and also abrasions. So if you've ever gone swimming and found yourself like underneath a wave at the wrong time, you can get rocked in that surf zone, and you're going to feel the effects of that rolling action within the wave, and you're going to feel the abrasion of the sediment that's swept up with that wave. So you can get pretty scratched up from that force, and also the impact and pressure of waves on the shoreline. And then obviously this would be magnified quite a bit with storms, because storms transfer a lot more energy a lot faster in coastal environments. So yeah. So here's some other examples of abrasion that you've probably seen in coastal areas. The smooth or rounded sediment deposits, that's all from just the wave action constantly picking up and redistributing that sediment, and the sediment grinding up against other sediment, making them real smooth and polished. And then you can see that here with this cliff face as well, where the waves have undercut this cliff area and produced that pretty cool little archway there. All right, I'm going to stop part 2 of the lecture, and then we'll talk about some landforms that exist in coastal areas in part 3. So rock on.